Okay, so we're going to start just here in number 5. It looked like a lot of people were making some very good progress with number 5. Hopefully it's something that maybe you kind of remember a little bit from 105, but let's see if we can talk through this one. So we're going to fill in the table with 4 solutions of that equation, 3x plus 2y equals 12. Now this equation is different from all the equations that we saw the last class, because all the equations we saw last class looked like, 3x minus 8 equals 7. And there's only one variable in that equation, whereas there are 2 variables in this equation. So we're not looking for an answer like x equals 2. We're looking for a whole collection of answers, and the answers are going to have an x and a y. So the easiest number that I like to pick, you can pick any numbers you want for x or y. The easiest number generally is just 0. If I plug in 0 for this x right here, then essentially it goes away. So I'm just going to ignore this in my mind and then say, okay, I've got 2y equals 12, and that's an equation I can solve. How much is y? 6. So that's easy enough to do. Are there questions on where the 6 came from? Like if you get that, then you can fill in anything you want in the table, but if you don't get it, the rest of the table is going to be mysterious to you. So speak now. Are there questions on that 6? Okay, same game, but now I'm going to choose y equals 0, and then I'm going to figure out what x is. So if we let y equal 0, then this term right here is nothing. So we cross it off. 3x equals 12. How much is x? 4. So we've now got 4 and 0. Those are the 2 easiest ones to find. Sometimes those are the only ones you need to find, but apparently we need to find 4 solutions altogether. So you can pick any number you want to, and sometimes you'll get lucky and it'll be nice answers, and sometimes it won't be so nice. So if you pick something like 17, don't expect it to be nice. I'm going to pick 1 and hope for the best. I don't know what's going to happen, but if it's a fraction, we can handle it. If we plug in x equals 1, I don't get to do that thing where I cross things off anymore. So we just actually have to solve some equations. So I'm going to copy that guy down here 3 times. Instead of x, what am I picking? I'm picking 1 plus, and then we copy everything else. 2y equals 12. And I think it's worth writing that equation down until you get a lot of practice with solving those kinds of things. It's really worth writing down. So 3 times 1 is 3. And then how do we move the 3 over to the other side? Subtract it. So then we get 2y is 9. And then to solve for y, divide by 2. And oh well, we got a fraction. It's okay. Y is equal to 9 halves. Or if you prefer decimals, which a lot of people do, 4.5. Any question on that number? And it's totally okay if you didn't have 4.5 in your table. You can pick any number you want for x or any number you want for y. Just do the work, fill it in, and then get some points. So my points might be a little different than yours, but all I'm going to do is rewrite them in our standard, like here's how they look before we plot them. Which one goes first every time? X. X always before y. If it makes it easier to remember, it's in alphabetical order, right? In the alphabet, X and then Y. So I've got 3 points, and I'm going to plot those 3 points, and I think that we are good at plotting points, so we won't take too long to plot them. 0, 6. Is it straight right or straight up? Point 0, 6. Where is it? So straight to the right. Everybody point. Straight to the right or straight up? Okay, see mostly ups. All right, math is a democracy. We'll say it's up. Here we go. That was a joke. It's okay to laugh. Yeah. Okay. 0, 6. 4 is, it's not okay to sarcastic laugh. That's all right. 4, 0 is there, straight to the right. And then one more point for me is 1 and 4.5. I'll plot it in red. Over 1 to the right, up 4.5 is here. You might not have the same points. That's fine. But the idea is if we connect them in a reasonable way, we're all going to have the same line. And so with a straight edge, if you have one, draw a line that comes close to those 3 points. I'm never going to take points off if you don't put arrows, but I'm going to put arrows just to really stress this goes forever both ways. And I think I mentioned on the first class that sometimes people just connect the first point and the last point that they drew, and they say this is the line, and they just draw that and they stop, and then it's just empty. And that, I mean, the line doesn't care which points you picked, right? The line goes. It doesn't matter what your table says. So really make sure you don't just start and stop at the points that you plotted. It goes forever in 2 directions. Any questions on graphing the line? Okay. So let's take a step back. Thank you for working on this while I took a few extra minutes to grade homework. But can we go to page, so it's actually page 11, but I don't think you'll find the page number in the packet. It's covered by a graph. But at the top, it looks like this. Everybody find page 11? Easier to find page 10 and then go one page further. Okay, so we're starting right here. It says class number 3. And before we do, we'll make one quick announcement that is not about this class, but just something I wanted to share. It's here. So there's an event happening at UMass Amherst. They would like to extend an invitation to join them for their upcoming Career Blast 2013. What does that mean? It means that there are approximately 140 employers going to UMass Amherst at this time to meet with potential employees, maybe you, if you are interested in joining the workforce. So if you want to know exactly which 140 employers are going to be there, there is a link you can go to right here, umass.edu/careers. It is a free event open to the public, and it might be a good opportunity to make some connections if you are looking to find a job maybe after this semester. I think it would just be kind of a meet and greet, maybe bring a resume if you have it, but you can just go and get information. Yeah, Michelle. I'm assuming that it went to everybody. I got it yesterday. I share it with you guys, but I'm assuming that if it hasn't been emailed, it will be at some point. The event is still a little ways away. It's in February. February the 20th, 10 to 3. That said, I'm not planning on reminding you guys about this on February 19th. So if you are interested, or if you might be interested, make a note. See me right after class. I can email you this document. It has all the information, or you can just go directly to that website. Any questions about this? Okay. So we'll take our quick look at the calendar and then we'll dive back in. Today is January the 30th. We cover section 1.1. It's all about linear models. Did people have any luck watching the video of the first class on YouTube? Raise your hand if you had a chance to watch that video on YouTube from the first class. So you watched part of it? Yeah. Did anybody have any trouble watching the video, either finding it or technological issues? Okay. All right, so that's that. And just wanted to give a sense of what's coming here. Our very first quest, whatever that means, is happening on February the 8th. So if you look in this column right here, it says quests and tests. Tests are going to be full period and on about 2 chapters of material. We're going to have only 2 of them throughout the semester. The first one isn't even happening until off the screen here. Quests are also full period, but they're not on 2 chapters, they're on less than that. So I don't want to call it a quiz because I think it's bigger than a quiz, but I don't want to call it a full-on test. The tests are going to be these really cumulative, comprehensive type things. Davis. Where are we? 3.1, it is not a typo. No, not a typo. Yeah, good catch though. Okay, so in terms of that quest, again, it's a full period thing. I will give you resources like practice things to prepare for that assessment. We'll talk about time and we'll talk about all kinds of things, but just a heads up that it's not too far away, February the 8th, and it's essentially going to be on everything that we cover in classes 1 through 5. Today is number 3, okay? All right, okay, so more on that coming. Let's go back here to page 10, and we'll start with number 1. And can we go to Katrina? Could you read number 1, please? Thank you. Davis, number 2. 2. Hole punch. We. Okay, thank you. All right, so we have this setup. We're talking about constant rates of change, and let's look at an example. Suppose an individual works X hours at a salary of $7.50 per hour. What's minimum wage right now? Okay, do not turn us in. We're okay. So we're illegal here at this 7.50 an hour, but it's just an example. So 7.50 an hour. And we're going to fill in the table of values showing the wages W in dollars earned for the number of hours worked X. So first we got to grapple with what these letters are. We're just introducing letters. The idea of earning 7.50 an hour is one that's very familiar to us, but we're tacking letters on, and sometimes that abstraction can make it a little bit tougher to understand what's going on. So looking in the table, you can see that we have X is the number of hours worked. Could be 0 hours, 1 hour, 2, 6 hours, 10 hours worked. And then W is the thing that we're going to use to symbolize the wages earned in dollars, okay? So if we work 0 hours, how much money are we going to make? $0, that's easy enough. If we work 1 hour, how much do we make in that hour? We make $7.50. That's our magic number right up there. $7.50 per hour, $7.50 every hour. So we make $7.50 there. In 2 hours, how much do we make? It's 15 bucks. But then we get to 6 and 10. So see if you can figure out, without doing 750 plus 750 plus 750, see if you can come up with a better way to find the wages for 6 hours. Once you've got that table filled in, go ahead and plot all those points on the graph paper at the bottom right and check with your neighbors. All right, so we've got our table filled in. I feel like folks got the table right, and then we plot some points. And what do we notice about those points? Seems like there's a line happening there. So linear is the right word to use. And with a straight edge, you connect the dots. And it feels like that right there tells us the relationship between how many hours we work and how much money we pull in wages. So let's see if we can go to part B here and answer some of these questions. Can we go to Dan all the way in the back? Okay, how much do we earn? Every increase of an hour, we earn another $7.50. Yes? Did it make a difference that you went from 0 hours to 1 hour versus going from 1 hour to 2 hours? Did your hourly rate change? No, it was a constant, $7.50 an hour. Does this hourly rate change or stay constant? It's a constant rate of change. Sam? So we could have something where maybe in the first 40 hours per week, you earn $7.50. But what happens after 40 hours for some jobs? You get overtime, and it's time and a half, and now we're at $10.75 or something like that, right? And so it wouldn't look like this straight line if the rate of change were not constant. So we might have some kind of more complicated thing. Exponential is a nice word to use. Yeah. For most of what we're going to do in the beginning parts of this class, it's going to be lines, but we really want to focus on this idea of a constant rate of change. Every time you walk from one point on this line to the next one is 1 hour to the right and $7.50 up. It doesn't change. Okay, let's go to, we're in the back now, Joe, for each. Okay, thank you. So moving on to part C, it says write an equation for W in terms of X. Now there's this key phrase here that this is the first time we are using it in this class. In terms of. That's an important phrase, and we're going to see it a bunch. So here are the two options. What does it mean to say an equation for W in terms of X? It either means W is equal to something with X's in it, and I don't know what that equation is yet, or the other way. X is equal to something with W's in it, right? Those are the two choices. So to be very clear, when we say W in terms of X, it means write an equation of the form W equals something with X in it. Whatever you see first, W, that's the thing that's by itself. Write it down first. In terms of equals. And then I don't know what goes on the other side. It's usually pretty complicated. But that phrase is a key phrase that you're going to add to your list of things that you know, right? Whatever letter is first goes by itself. So can you guys write an equation for W in terms of X? And again, check with your neighbors. Some people will have this right away. Others, it will take a little more time, and that's fine. Okay, let's write the equation down here. Again, it's W in terms of, so it's W equals. Let's hear from somebody we haven't heard from yet today. What equation do we have? Okay. 750 times X. Do we buy it? 750 times X. I think that sounds good. Okay, and then we've got the graph over there of all the different number of hours we could work and the salaries we would get. If we're ready, we'll move on to the next page. And we'll go to Sam. Can you read E? Yes, Sam. That's real important. Can you read it again? Okay, so two more vocabulary phrases right there. Dependent versus independent, and it can be really easy to confuse them because they're exactly the same long word except for two little letters in the front of one of them. So how are you supposed to know which one is which? Well, whichever one depends on the other is called the dependent variable. So does how much money you make depend on how many hours you work, or does how many hours you work depend on how much money you make? Yeah, it feels backwards, the second thing, right? It feels like the first one. You work a certain number of hours, and as a result, you get paid a certain amount of money. And so because the wages depend on how many hours you work, W is the dependent variable. X is independent. You are free to work as many hours as you want, maybe, and then we're going to pay you accordingly, okay? So X is independent in this case. Now, I wrote this little kind of mnemonic device. Mnemonic device is just something to help you remember. It was late at night. I was pretty tired when I wrote this, so it made sense at the time, but if it doesn't now, you'll have to forgive me in advance. We'll go to Daniel. You. Okay, so you've probably seen Pirates of the Caribbean, at least you know the movie, and we know Johnny Depp. So the dependent one, imagine Johnny Depp on this island by himself. The dependent one is the one that is by itself, okay? Johnny Depp, dependent, by itself. So in the equation, W equals 750X, what letter is by itself? Is the W. So the W is like Johnny Depp by himself on an island. The W is the dependent variable. Yes? Yes. Okay. Let's go to, actually I'd like to skip past number 3 and we're going to jump to number 4. Jenny. Okay, thank you. So let's take a look at this AX plus BY equals C, kind of the first equation with the variables and also some other letters floating around in it. You guys have seen this equation before, I think, Y equals MX plus B. Seen that before? Well, we'll spend lots of time talking about what all those things mean. Here's another version of the same thing. AX plus BY equals C is a general equation of a line. I can't really tell you specifics about that line unless you tell me the values that A, B, and C take. So in the equation 3x plus 2y equals 12, what we're saying, A is the number touching the x. So how much is the A in this example? Is 3. Can you guys just write down B equals and C equals? How much is B and how much is C? Be real careful. Just compare the general equation to the specific one. How much is B? 2, and C is 12, right? Raise your hand if you have seen this beast before, plus or minus square root of B squared. Okay, I get tired of writing it, but okay, so we've seen it, right? A bunch of us have seen it. It's going to be important for us to be able to identify the A, B, and C in equations in order to use this crazy complicated quadratic formula. We'll get there, but I think it's a nice thing to do, just identify, make sure we can identify what the different letters represent. Okay, so so that equation right there, 3x plus 2y equals 12, is the one that we graphed at the very start of today. So how do you graph a line when you don't know what to do? You pick points. You make up any number you want for x, and you find y. Or make up any number for y, and you find x, and you plot them. How many points do you need, technically, if you're going to draw a line? We only need 2, right? If we're being as efficient as possible, how many different lines go through this point right here? 1, 0, 5, too many? How many lines go through the blue point? Yeah, I haven't given you any more information. Are there any lines that go through the blue point? No? How about this one? Are there any other lines that go through the blue point? Yeah. Once you start drawing them, you see there's a lot of freedom. There are infinitely many lines that go through that blue point. How many of those lines also happen to go through this blue point? How many lines go through both of the blue points? Just 1. So if we're trying to be super efficient and we're drawing a line, all we need are 2 points. As soon as you have 2 points, you know everything. That said, it probably wouldn't hurt to get a third or even a fourth point. If I had made a mistake, let's say that the first point that I plotted was this one right here, and I got that right. If the second point that I plotted, I made a mistake and I did my arithmetic wrong or my algebra wrong, and I got 8 instead of 4, well, I'd be dead wrong, right? I'd say this is the line. But if I had a third point there to kind of check my work, and if the third point I plotted was where the red one is and it was correct, then I'd say, okay, wait a minute. 1, 2, 3, something is funny here, right? Every time you plot another point and it's still on the same line, it's more confirmation. You add confidence to what you've done. So yes, 2 points at the bare minimum, but it doesn't hurt to add a third one just to really make sure. Okay, let's come down here to number 7, and we'll come up here to Ben. Okay, so 0, 6, and 4, 0, are they on your graph? Yeah, and maybe you pick those points, like I happened to actually pick 0, 6, and 4, 0, but if you didn't pick them, then it might not be clear. It might look like it's close, but it's hard to tell. And really anything on a graph is hard to tell. All we're doing is estimating. So, so those 2 points lie on the graph, and now we'll come down here to an important vocabulary thing, and where are we now? Where to Glenn? Since? Okay, great. So 4, 0 is this blue point out here. It hits the x-axis. We know the x-axis is that horizontal one. And because it hits the x-axis, we call it the x-intercept. And I just want to highlight that, for example, what are the coordinates of this point right here? Just making one up. That's -7 and 0. And how about this one over here? That's -10 and 0. And if you look at the 3 points that are on the x-axis, they all share a common trait. What's true about all of them? The y is equal to 0. So this is nothing specific about this particular line. If you are on the x-axis, the y coordinate is 0. That is a fact. So anytime, this is what Glenn read to us here, anytime you are looking at a point where the y coordinate is 0, you're looking at the x-intercept, okay? And then it goes the other direction too. Can we come up here to Adam for the second since? Okay, thank you. So that's the same thing, but now on the y-axis. The coordinates of this point right here, 0, 6. The coordinates of this point up here, 0, 9, just making something up. What's the same about both of those points? The x is equal to 0, okay? Now this is something that, for me, the way that I remember which one is 0 on the x-intercept and which one is 0 on the y-intercept is that I remember that there's some opposite thing happening here. If the y coordinate is 0, you are looking at the x-intercept. If the y is 0, it's the x-intercept. It's the opposite. It's not x equals 0, x-intercept. It's the other one. And then on the other side of things, if the x is 0, you are looking at the y-intercept. Right? So there's always this opposite thing happening here. Do I understand what I mean by opposite? X and then y, y and then x. Okay, let's come down here to number 8, and we are now up to Subtab. Can you read number 8, please? Okay, x over 4 minus y over 6 equals 1. We could fill in a big old table like we did right up above. This one seems a little bit tougher because of all the fractions, but let's just see if we can fill in a mini table where we plot only 2 points, the y-intercept and then separately the x-intercept. We're going to be as efficient as we can be. We're after 2 points and only 2 points. We're not going to find a third one to try to check our work. So if you are at the y-intercept, some letter is equal to 0. Which one? One vote for x. If you're at the y-intercept, what letter is equal to 0? A couple more votes for x. X is equal to 0. It's true. And down here, if you're at the x-intercept, so y is equal to 0. So then what we're going to do is copy this equation right here, but instead of x, we're going to put 0. So that x over 4 becomes 0 over 4. Minus, everything else gets copied. Any questions about the replacing that we just did? X became 0, everything else copied. Okay, this is an equation with only one letter. Your job is to find out how much that letter is equal to. 0 divided by 4. Some people get confused by this. 0 divided by 4 is a nice number. What is it? It is 0. If you continue writing 0 over 4 like line after line, what that means is you don't understand that 0 over 4 is 0. 0 divided by anything is 0. I'll copy this part right here. And then 0 minus y over 6. Well, I don't need to write that 0, do I? I think this is just negative y over 6, isn't it? 0 doesn't affect anything. So we have to now solve this equation for y. And the best way to solve this for y is to multiply both sides by the magic number. 6 is good. Negative 6 is a little bit better. We're going to multiply both sides of this equation by negative 6. If it's not clear why we're doing that, then bear with me, and you'll see why. Multiplying both sides by negative 6 is a good thing. What happens with these 6's here on the left? They cancel. That's why we did it. We were trying to get y by itself. Y had a division by 6. We undo that by multiplying by 6. What happens when you multiply two negatives together? You get a positive. That's why we put a negative 6 instead of just plain 6. So I'm going to change those both to plus. And if you can read through all the gobbledygook, then I think we're right there at the end. What do we have on the left? It's just y. That's what we were after. So we're good. Y equals 1 times negative 6, negative 6. And so we now have our y-intercept. And I'm just going to write it in final form down here as an ordered pair. There are two numbers. A y-intercept has two numbers. It's a point. It has an x and it has a y. How much is the x at the y-intercept? It's 0. How much is the y? It's negative 6. That's what we did all the work to find. That right there is the y-intercept. 0, comma, negative 6. I think it's a really good idea to write this part at the start of the process. I'm finding the y-intercept. I know right away x equals 0. More than just saying plug in x equals 0, which you have to do to get y, you're also giving yourself an opportunity to know where the 0 goes. You wrote it. X equals 0. Great. The first number is 0. Okay. So we'll play the same game to find the x-intercept. So can you guys work with your neighbors and see if you can find the coordinates of the x-intercept? See if you can follow a similar process. Okay, so without all of the details that you guys just did, it looked like most of our groups were around to the 0.4, 0. Make sure you write it as an ordered pair, and make sure you put the 0 in the correct spot. And then we can plot these 2 points, 0, -6, and 4, 0. If you haven't done so, go ahead and plot those 2 points on the axes. And if you have a straight edge, connect the dots. Any questions on that? So what we've just done is graphed a line. We had an equation, x/4 minus y/6 equals 1. I'm a big fan of graphing lines by doing exactly this. I called it the intercept method right up here. It means find the 2 intercepts and connect the dots. And I think finding the intercepts by plugging 0 in for some letter is the easiest number to plug in, easier than what we did up here for this equation. Because, for example, right here, I just picked x equals 1, and then I had to do all of this work, which I think is more work than plugging 0 in down below. Okay, if we're ready, move on to the next page. And we'll go to number 9. Can you read number 9 for us? Okay. Okay, thank you. So lots of words in here. We got to be really clear what x and y represent. So I'm just going to circle here. X is the number of minutes. So that's how long the balloon ride has been happening. And y is the altitude. Okay? So we've got how long the balloon ride has been happening and the altitude. Since releasing the air from the balloon. All right, part A, circle all true statements about the equation y equals -200x plus 800. There are 6 sentences here. 3 of them are true, 3 of them are false. Circle the 3 sentences that are true and check with your neighbors. Seems like most folks are finishing up finding the intercepts and maybe plotting some points. So I've circled the 3 things. I think all the groups came around to this idea of independent versus dependent. And in terms of, it's easy vocabulary once you have it, but it's also easy to get wrong. Okay, the intercepts, without showing really any of the details, I have 800 for the y-intercept and 4 for the x-intercept. I am going to make sure that I ask you guys to write them out as ordered pairs, though. So for the first one, where does the 0 go for my y-intercept? Is it the x or the y? Yeah, for the y-intercept, it's the x, right, the 0. So this is 0, 800. And then for the x-intercept, the y must be 0. So we got 4, 0. And we can plot those points, 0, 800, 4, 0, and we connect the dots. And really, for the first time in looking at this problem, I can kind of see what this balloon is doing. Is the balloon going up or coming down? Yeah. Balloon is coming down. I really wasn't sure whether we were on our way up and then we turn around, or we were just going up forever, or we were coming down, and now we can see. Now it turns out there is information in that equation that with a little bit of practice and training, we can look at that and know, yes, it's definitely coming down without doing all of the plotting points. Some of you might already know what I'm after, but for right now, certainly we can plot the 2 intercepts and then draw the line. It's fine. So if we come down here to part C, I think we're up to Teresa. Okay, so the y-intercept was at 800. Now, if your sentence doesn't have the number 0 in it, then you've missed part of the information. The y-intercept has a 0 involved. So I know not everybody's had a chance to write down a sentence, but let's see if we can work through this. The x-coordinate is 0. I have to remind myself, what does x mean in this problem anyway? Well, I circled it up there in green. X is the number of minutes. So how many minutes away? 0 minutes, or even less than 1. Like right at the moment we release the air from the helium balloon is when we start this experiment. So 0 minutes into this trip, the y is 800. Okay, I need to remind myself what is the y. It's the altitude. So the altitude is 800 something. 800 what? Feet. Altitude is in feet. So after 0 minutes, the balloon's altitude is 800 feet. And we can write that. Yes, Sam. Yeah, the y-intercept is the height at which she starts releasing air from the balloon. It's great. And in fact, I actually don't think that I think my sentence is a little bit awkward. Saying after 0 minutes seems awkward to me. So generally, instead of this phrase, I'm going to replace it with a single word. And that word is initially. Initially, the balloon's altitude is 800 feet, but Sam is saying the same thing, right? As soon the moment she starts to release the air, the height of the balloon is 800 feet. So I'm going to write the rest of my sentence here. Initially, the balloon's height is 800 feet, the balloon's altitude. And I'm going to say that under no circumstances am I looking for word for what I have here. If you have it, that's fine. But all you have to do is convey to me that you understand what the two letters represent in this problem. The x is how long it's been, the y is the altitude. You need to get the how long and the altitude both in there, and you need to make sure you have two numbers. If your sentence only has 800, you're missing something. You're missing the 0 part. Now, even in my second sentence, even though the 0 isn't in there, where is the 0 really in that sentence? It's in the word initially, okay? So it's there. Okay, part D, same idea. What does the x-intercept mean in this situation? Okay, write a sentence. You've got an example one up there in purple. Basically, it's going to be the same thing, but with different numbers. All right, so I've written my sentence, but I've left the numbers out. It's exactly the same sentence every time with this setup. So after how many minutes for the x-intercept? After 4, put this in a different color. After 4 minutes, looking at this point, what's the balloon's altitude? 0 feet, 4, 0. You can just keep using the same sentence, but change the numbers. Again, I think this sentence is a little bit awkward. I think there's a better way to say the balloon's altitude is 0 feet. Where is the balloon if its altitude is 0 feet? It's on the ground. So I'm gonna update my sentence. I'll say this is a full credit answer. You got it perfect, but maybe a little bit more natural is to say after 4 minutes, the balloon hits the ground. And it feels to me the improved sentence, which is in blue for both of them, always comes for me after I write the standard sentence. Like I write the standard thing, and then if I can make it sound better, I will. But I start with the standard thing. Any questions on that? Anybody notice anything about the way in which this balloonist is hitting the ground? Just a smooth landing? Yeah, this is a pretty abrupt, like it might have been a little bit better to use some more lift at some point right before we're coming in. It might have felt a little bit nicer if we could have kind of come in something like that, where we sort of slow down on our descent. This was just straight down. Okay, moving on to number 10. We are around here to Dan in the front. Okay, I think there was an extra word in here. 30-second spot on TV costs $150, and a 30-second radio ad costs $50. Okay, so which one is more expensive, the TV or the radio? TV, 3 times as expensive. So let's see if we can go down here to part A. We'll go to Dave. Okay, so let's see if we can come up with the equation. I think this is the hardest part of the problem, if I'm being honest. I think the rest of it is pretty straightforward. It's fairly procedural, but I think coming up with this equation is the tough part. So I give it to you with your neighbors. See if you can come up with some equation. It's going to have X, it's going to have Y, it's going to have 150, it's going to have 50, it's going to have 3,000. Very carefully and slowly, see if you can come up with some equation that relates all that stuff. Okay, so let's come back together and just check in. I've got a few points. You might have different ones, but I'm hoping we all have the purple ones, which are the intercepts. 0, 60, 20, 0. Those are the 2 intercepts. Frankly, that's all you need, but you can spend another couple of minutes filling in and finding some other points. Hopefully we get this downhill line right here. And what I want to do is make sure we can interpret the 2 intercepts because they mean something. So up here we've got the point 0, 60. And then down here, we've got the point 20, 0. And those 2 intercepts mean something in terms of TV ads and radio ads. So on the next page, we'll go to part D. Who was our last reader? Is it Michelle? Dave, did you read? Michelle, did you read? No. Go ahead, part D, please. Okay, this write a sentence in plain English you're going to see throughout the notes. This is, I think, part of the most important thing to get across in an algebra class is your job is to be able to translate things out of the common algebra speak and into plain English. If you can interpret something in plain English, then you understand it. So let's write down the y-intercept. It was 0, 60. So we want to make sure we understand what that thing means. So that 0 was the 0, the TV or the radio? Which one was X? It was the TV ads, and then over here is the radio ads. So what does it mean? We can buy 60 radio ads, and then what happens? We're out of money. We can't buy anything else, which is fine. So we can buy 0 TV ads and 60 radio ads. Great. You can write the same sentence for the next part, which is about the x-intercepts. I do think it's a little bit awkward to say buy 0 TV ads, just like we said the balloon was 0 feet off of the ground. So maybe a little bit better is we can use all of the budget on 60 radio ads. Again, it doesn't have to be word for word. Just looking for you to convey the idea that you understand exactly what these 2 letters X and Y represent. Okay, take a moment, see if you can write a sentence in plain English for part B. Can somebody that we haven't heard from yet share their sentence for part B? Davis. Oh. Good. 20 TV slots, no radio slots. Super. There are a lot of variations that will get full credit. Okay, so there's this group activity here for which you have exactly 29 seconds. Okay, so you're going to spend some time after class looking through that. I think it's a nice activity, but I think it's okay that we didn't get a chance to do it in class. I like what we covered today. As usual, there is an answer key that follows the group activity. It is right there. So as you're working through that later, maybe you can check your answers. And then I just want to pause for one moment here on the homework. So is everybody on this page here? Page number right there, page 16. The middle of page 16 is the homework. So the only reason I want to pause, okay, there's a reading assignment, that's usual. You're going to complete the group activity. Okay, you're going to start and complete the group activity. I'm not going to collect that. You're going to do the textbook homework. I'll check that. If I didn't check your homework today, stick around for just a minute. But there is this thing called GeoGebra, which has to do with computers. And I just want to point out it is different than the normal assignment. So just give yourself a little bit of time to make sure you have time to do this computer part of the homework, okay? With apologies for going over, we'll see you guys on Friday. Have a good day.